Hello friends, welcome back, and in this lecture we are going to see that how we can use the sigmoid function in a Python code. You will be preparing the machine learning models, right? So in that case, if you are preparing a model which is based on the neural networks, then in that case, based on your scenario, you might need to use the sigmoid function. So we are just going to see a simple example that how the sigmoid function within the Python code can be utilized. So on the top, I have imported the NumPy library. So NumPy library, if you know, this is a very vital library when you are studying the data science and the feature engineering, or you can say the neural network or machine learning, anything. This NumPy library you must need to be aware of. What does it do, right? So whatever we are doing, those are the important things from this library which are really needed and which you should know, right? So here in the second section, I have written the function using Python. You if you write a function, you need to define it with the def. So I have given the name as sigmoid, and this sigmoid function is taking one argument, and then it will be returning the sigmoid value. And you know that the sigmoid is like 1 by 1 plus e raised to the power minus x. So this is the function written here, the logic written here, the actual conversion logic written here, and you already know that there is no such function in the Python, which is named as sigmoid, right? So we have to write our own. So I have written our own sigmoid function. So here what we are going to do, we are going to convert an array of values, right? The array of values is between -2 to +2, right? We have taken the values -2, -1, 0, +1, +2. And from the definition of sigmoid, we already know that whatever value you provide to sigmoid function, it will always be between 0 to 1, right? Doesn't matter if it is negative, doesn't matter if it is positive, and how big is it, doesn't matter at all. It will always be a value between 0 to 1. So here we are creating an array, input values, np.array, and then output values we are taking from the sigmoid function. So we are passing this input values array to this sigmoid function, and since we are passing the array, so every element of the array will be worked upon by this sigmoid function here, and then each of the value in this array will be converted into some value which will be between 0 to 1. That will be a real value, right? That will be a decimal value, right? That will be a real number basically. So let us see after running this. So first of all, let me run this section. That is fine. Then this section, that is fine. And now this section I want to run. Yeah, so here you can see the input values are -2, -1, 0, +1, and +2. And after the application of the sigmoid function, they have been converted into the values like this. So these values, you can see these values are between 0 to 1 only, right? There is nothing else. So doesn't matter what value you provide here. If you provide -100, then also if you run it, you will be able to see 3.7 this, right? E raised to the power -44. This has been written here. So this is a value which is, don't consider this as greater than 3, because here you can see e raised to the power -4, right? So this has been scaled between 0 to 1 only, right? And if you provide like something like 10, then you can see, yeah, here again it's e. So smaller values are really giving you the real field, right? So it's like -2, -1. These values are giving you the real field. But the thing is that when you're providing the bigger values, then obviously they have been converted into the in the terms of the e, exponential, and they are ultimately greater than 0, but yeah, less than 1 and in decimal values. So I hope you are now comfortable using this sigmoid function, and you must need to be aware that you need to write this function your own. So in the next video, we are going to see that how we can use the sigmoid function to create a real world application. So till then, have a nice day and bye bye. Thank you.